So today we are going to discuss the reduction potential of carbon monoxide, hydrogen and mixture of carbon monoxide and hydrogen in blast furnace. So in this video we will explore how iron oxides are reduced inside blast furnace by all the three composition, that is 100% carbon monoxide, 100% hydrogen and finally the mixture. So we'll break down the science, the kinetics and why the synergy of carbon monoxide and hydrogen is so powerful for modern green iron making. So the blast furnace is essentially a counter current reactor. As we all know, solid descent while hot gases rises, and this setup allow maximum heat and mass transfer. As iron ores travel downward, they get reduced in stages from hematite to magnetite to wustite and finally to metallic iron. Uh, as we must be knowing, there's wustite reduction, where the reduction of wustite Fe₄O is the most critical stage. Yeah, almost 70% of hematite oxygen passes through this Fe₄O stage, but here is the challenge. Fe is slower to reduce than earlier oxide, and its efficiency largely determine how well furnace perform. So now coming to our all reduction activities with the help of CO. So at around 900 degree Celsius, CO takes oxygen from Fe₂O₃, Fe₃O₄, and FeO to produce CO2. So this process is mildly exothermic, but it has got a challenge. The generated CO2 at high temperature react with coke in Woodward reaction consuming fuel. Also, excess CO can cause carbon deposition that attack the furnace lining drastically, and many times it's created a big problem in the furnace stacks, blast furnace stacks. Now coming to CO kinetics and bursting effect, reduction by pure carbon monoxide starts slower than hydrogen but finishes faster. This we must have to remember. And why? Because CO has the ability to crack or burst the dense iron shell that form around the ore particle, opening new gas pathway, and that make it very effective in later stage of reduction. So coming to the reduction curve, which already elaborate all these things. Now coming to the reduction by hydrogen, where hydrogen reduces iron oxide by making water vapor. The final FeO2 Fe step is endothermic, but above 821 Celsius, hydrogen becomes more thermodynamically efficient than CO. It also moves 3 to 5 times faster than CO thanks to its much higher diffusivity. And at 900 degrees Celsius, the hydrogen utilization factor is about 37% higher than CO, which is at this stage 30% only. So hydrogen can reduce FeO more efficiently, and in fact just 1 kilogram of hydrogen is equivalent to more than 7 kilogram of carbon in reduction term. So this shows why hydrogen injection is gaining attention for green blast furnace operation. Despite starting fast, reduction with pure hydrogen slows dramatically. That's because a dense non-iron film, non-porous iron shell forms around the ore particle, blocking further penetration, and this makes the pure hydrogen less effective in completely reducing the core at practical time scale. Now coming to the combined effect of CO and S2. When we put CO and S2 together, amazing synergy happens. CO does the shell cracking and hydrogen quickly penetrates inside with its higher power. The spectacular part is 75% CO and 25% hydrogen mix can cut total reduction time to about 90 minutes, much faster than pure CO at 120 minutes and pure hydrogen at 240 minutes. So we can say that the chemistry is helped by the water gas shift reaction. CO plus water vapor makes CO2 plus S2, and This is catalyzed by freshly reduced iron, so even a small hydrogen addition regenerate themselves during the reaction, multiplying the effect. That's why you do not need massive hydrogen to see the real benefit. Now coming to the hydrogen percentage, impact of hydrogen percentage. So we can see that adding up to 5% hydrogen to CO stream can boost reduction rate by roughly 2 to 5% for each percent added. And beyond 5%, however, the boost flatten out because diffusion, not regeneration, dominates. So the first few percent of hydrogen addition gives biggest return on investment. So as we have seen the significance of 821, and above 821 hydrogen becomes thermodynamically more efficient compared to CO, and that details has been shown in this slide, as we can see. And this also we have discussed that the iron ore reduction time comparison with the help of a mixture, it takes only 90 minutes, whereas pure carbon monoxide takes 2 hours, whereas pure hydrogen takes 4 hours, which conclude that mixture of 75% CO and 25% only hydrogen create miracle as far reduction time is concerned. So to wrap up, at lower temperature CO is more effective, but above 821 Celsius hydrogen takes the lead. Together they complement each other brilliantly, saving coke, establishing furnace operation, and improve productivity. Understanding this synergy is critical not only for today's blast furnace operation but also for transition towards carbon lean and hydrogen rich iron making. Thank you.